I'm Mike Leye. I work at CU Boulder. I'm not a professional developer. I'm just a much-time user. And if my video freezes, I think we have to live with that because I don't have a camera on this system. Yeah, I guess I can't do anything about that. So that's my iPhone being with an extra server. All right, sorry about that, but you can hear me, I hope. So otherwise, shout out. Conda versus Anaconda versus Miniconda. So I think in being productive with these tools needs a little bit of understanding, and the dependency nightmare that actually all software systems have exists for Python just as much as C++ and C, and I think it's a little bit also caused by the fact that we're using open source and we don't have a commercial entity that helps us navigating this better, because open source is always constrained in documentation and usability a little bit. But I think it's an okay deal that we are having, that we get all this stuff for free, but we have to invest a little bit of learning in understanding it. So I get a few. There you go. I just wanted to check. I can see the chat. Okay, so if anybody wants to say anything in the chat, I can actually see it. Okay, I see many people didn't get the slides. Interesting. Okay. All right. Yeah, you will get the slides, so don't worry about that. So I can see the chat now at the same time I'm sharing, so that's good. So I guess people still can hear me. I got some weird audio signals that something was going on, but I think, okay, great. All right, let's start. So these are the polls. So yeah, 3 different terminology, and I'm going into that. The first thing you need to get to understand, Conda is a tool. Conda is a command line tool. Even if you have it in a GUI, or using this Anaconda navigator, it's actually calling the command line or an interface to this tool. So in its bare bone development, it was started as a tool, and then the GUI was put around it, and yeah. So the biggest power you have and the biggest flexibility, and yeah, and I think also the biggest confidence on knowing what's going on is if you use the command line tool. And so I think you can stay for a while with the Anaconda navigator. I've used it a little bit, but at some point, also maybe it was still in the beginning, the GUI gets stuck, and I just felt helpless that I don't know what's going on, why the GUI is not going forward and things like that. And on the command line in a terminal, you just get the immediate feedback, what's going on. So sometimes it's not immediate because the dependency trees are growing so much that Conda becomes slow, and I can talk a little bit about that later. But you get at least a direct visual feedback of what's going on. So I think that's helpful and gives you a lot of power when you work through it in the terminal. So some people, or many people believe that Conda is just Python, but that's just not true. It's really used mostly for Python, but it manages also binary libraries underneath, like C, C++, and Fortran. And it gets the dependencies for GDAL or for OpenCV or for SciPy. These are compiled Fortran libraries in. So that's the big power, and I think a slight advantage over virtual env, which is also a very popular containment system for Python environments. And I talk a lot more about environments later, so don't worry if you're not clear about that term. But yeah, the power of Conda is that it can package anything that is packageable and that can relate in terms of dependency to other things. So I mean, with version numbers, and some other package can say, I need from this other package that version number. And this kind of relationships, if that's possible to define somehow, then Conda can deal with it and can package it usually. And as an example, there's also a lot of R packages now directly available via Conda. So I think, even so I didn't try, but I think you can set up your R environment now using Conda as well. And the other big advantage compared to the older times was is that Conda removed completely for the first time, I think, the need for admin and root access. I know that pip came up with this user flag, so pip install --user, But interestingly, this is something that is recommended against by the Anaconda company to be using in connection with conda. Apparently, it clashes some kind of philosophies, and I also will talk about this a little bit more later. So if you're used to pip user install, you should not use it if you're mixing it with conda, which in general is also kind of iffy, but I cannot avoid it. I do it regularly, but in a clear fashion, like I have a step ladder decision process of when I do it. I can live with it, and I'm doing this for several years successfully. Even so, it is always iffy to mix pip with conda, unfortunately. All right. So let's go next step. So conda is a tool, right? So it manages these packages. So here in the next slide, you see conda versus Anaconda versus Miniconda. On the left side in the box, you see the tool in green, the tool conda. And if you install the so-called Miniconda distribution, then you just get a minimal set of packages, and it will grow over time by your needs. So the user that knows what packages exist will install this package, might install this, and then we'll just conda install package names, and these package names come with their own dependencies, and so over time you grow your software just exactly for what you need. Now, if you don't know what you need, I highly recommend the so-called Anaconda distribution, and that's just basically the same thing as conda. You get a conda tool, but it comes with a meta package, a so-called meta package installed, and a meta package, as you can imagine, I try to indicate with my bad graphical skills that meta package just means it's pointing to other packages that need to be installed. So if you do conda install Anaconda inside a Miniconda, you actually at the end have the same as somebody who installed in the beginning Anaconda distribution, just because that's how the things are organized. The meta package Anaconda is just a list of packages. And as you can see, for example, here in this graphic, Spicy Pie. Oh, by the way, can see people my pointer? Okay, thanks. So Spicy Pie has a dependency of a NumPy version, and this is automatically managed for you. If you install Spicy Pie, Spicy Pie will install NumPy for you. Spicy Pie is a package for doing spice things in OpenPlanetary, in case you don't know it. Yeah, so this is what conda does for you. It manages its dependencies and finds the right packages to make it all fit. And now imagine, this is of course a mass power relationship or permutation relationship. How many relationships do exist in these containers of all the different packages that exist? So conda has to check a lot of version dependencies with each other to find the match that satisfies as many as possible requirements. And sometimes it will just say it give up, and it tries it for minutes and calculates. Even in the newer versions, it was slow in the beginning, but then they made upgrades in 4.8 and 4.6 to make it really faster. But it still can take some time, and that resulted in some new things. That's new kids on the block. I forgot to make a slide about it, but there's very new kids on the block. It's called Mamba, and that's basically trying to be a drop-in replacement for conda with the same interface, but based on C++, while conda is based on Python and some other things. So yeah, but that's just a side remark. But I think once you're familiar with conda, if the speed bothers you, you could try out Mamba, and I don't know how far they are, but it's a simple conda install. You get the Mamba tool, and then you could try out if that works as well. Okay, let's go on. Quick summary on what we had so far. So this is one of the takeaways for today. For sure that you are not confused about these terminologies anymore. So conda is the executable, and that manages the packages. So not only Python, but also binaries from HDF library, Fortran, OpenCV, etc. Miniconda is the minimum set of packages for proper operation of conda itself, but also more. More on this later. And this is by default always installed in the so-called base environment. So use this if you know which packages you need for your use case, because then you save a bit of disk space if you need to, and you don't get so many packages that you even don't know if you need them ever or not. But if you don't know what you need, then Anaconda is a really good compromise. You get a gigabyte of data to download, but it really has most of the things that you will need for scientific work with Python. And as I mentioned, if you install Miniconda and then execute in the terminal conda install Anaconda, you actually get the same Python environment as somebody that downloaded the Anaconda distribution in the first place. All right. Right, let's go on. Conda environments. So important thing to understand, and it's basic, I don't think it's even avoidable, unfortunately. And I will talk about this in the next slide more. But really the whole modus operandi of Conda is based on virtual environments. So after installation, you have what's called a base environment. And if there's somebody out there who still have an environment named root, I actually would encourage you to wipe it really all and reinstall the whole Conda system, because that the root environment comes from a time where Conda was built so different that you might have craft over there that disturbs the operation and could explain some of the errors and problems you're having with Conda. So, and really even the main install of a whole Miniconda system is easy. You just pick this download from that link I sent around and you install it, go quickly through the dialog, and that's it. You're back at a base Conda distribution. That's really a thing of a minute as well these days. But I really encourage you, if you still have something called root in your Conda EMS and we practice the commands regularly during the presentation, I go to a demo mode and you can type it in with me or just watch me. I can show you how you find out if you don't know what environments you have in the command line. I know the navigator has some kind of display with it, but for a long time also the Anaconda navigator was navigator didn't allow you to easily determine which channels you use. I will talk more about channels, don't worry. So maybe it is possible now, but yeah, I gave up at that point and just focused on learning the terminal power. Yeah, a bit more explanation here on why I recommend you to wipe it. It's just really Conda suffered from its own success and became so popular that they developed so fast that they had to implement some breaking changes. And sometimes these changes did not clean up old parts of how Conda was used with new parts. That's why I recommend, if you still have that old systems, that you wipe it. And one interesting comment is people say when you have more than one environment, you create a lot of disk space. Conda actually tries its hardest to save disk space by hard linking the same packages from a so-called archive of these packages if the version number is the same. So it checks if it has to be the exact same version number, and then it will hard link it between different environments if it matches all the requirements within that specific environment. So if that's okay, it will hard link it. And that saves 50 to 70% in space in my personal testing, because some of the things for some more internal reasons that I also don't understand that could be improved, but they are not being hard linked. I think there must be some kind of library. The way a library works, it doesn't like to be hard linked, it finds it out and then it's confused or whatever. I mean, that's going too deep for my knowledge as well. But I have seen that it's not 100%, but it's more than 50% that you save because of this process. All right, then the next slide. Carlos asked how to get rid of the base prefix in the terminal. Actually, in the next slide, I will tell you why you don't want to get rid of the base prefix in the terminal. So wait for that. So the question that I also very often hear, or I can feel it in the eyes of people who listen to me, is do you need environments? And the too long don't read is yes, you do need, and here's why. It's not that you are an advanced Python hacker that would be the criterion for using more than one environment. And it's not even advanced Python usage. So using a lot of library, but not developing your own ones. Not even that would be the criterion. The criterion is the following: certain architectural design, which gives you the reason to work with environments of Conda. First, it gives you a peace of mind because the base environment could be accidentally messed up by some of the things I'm telling you during this talk. Not that I'm messing it up, but it's just a matter of reality of how Python libraries are currently either not existing on Conda, and then you need to have them in pip, or you want the newest up-to-date thing of a friendly developer that you know who for sure claims that you need to install the GitHub version because everything else doesn't work yet. So, and sometimes you just want that newest thing. And because of all this messing around, you don't want to mess around with a base environment, because the base environment has stuff that is used by Conda for its base functionality. It's the same reason why on Mac, you should never install Python library and do your science work with the built-in Python. Because when you mess that up, most likely using sudo and root passwords, then you actually can destroy Mac operating system functionality, because they're using Python for some scripting inside Mac OS. So in the same vein, I highly recommend you that you just get used to the fact of virtual environments. It's actually while you think, I only have one thing, I just want a set of working libraries, and you think that's it. Why would I deal with virtual environments? Trust me, it actually gives you the confidence that we are practicing here, that if it's messed up, so what? You remove it, you get it back. And while if your conda, your base conda is messed up, you can't use conda anymore to repair an environment, because the base stuff, the libraries that conda depends on, are now messed up. And that's why installing a basic working environment that I always name after the Python version, I call it always Py 3.7. Feel free to come up with your own version, but that's what I found best working for me. I always have a Py 3.7 environment or Py 3.8 environment that is based on these Python versions. And when I mess them up, I just remove them with my process I'm showing you here, and I'm back within 5 minutes. And if you have messed up your conda, then it will take 10 minutes. Okay, also not a big deal, but still maybe a hassle. And maybe you actually have another environment that was working fine, and you only messed something else up. But what you happened to mess up was the conda, and then you lost the other nice working environment. That wouldn't happen if you would have your work environment and then maybe a trial out environment, which is so easy to do with conda. So I highly encourage you, don't work in the base environment. All right. And what Carlos was alluding to is the fact that the terminal always shows you in which environment you are. This is why it says base. And that's a very good thing, a very handy thing, because should you have a reason to switch environments, this prefix always tells you immediately in the terminal which current environment is active. And that's important if you need to install things, because only by having that prefix, you know where you're actually installing that thing. So the prefix tells you, for example, and that's one of the most used problems of people working in Python, they did a pip install, and then they launched a Jupyter, and what they just installed is not available in Jupyter or in IPython. And they wonder why. They just installed it. And the problem is that there's more than one pip around on your system. And when you use pip install, you most likely did not have either environments available, or you forgot to switch on the environment in which you need that package. So, and this prefix really helps you to remind yourself that, oh, I need to activate the environment before I use pip install, because only then I know that that library will get there. So it's a cool thing to have this environment switches and a prefix that solves you from using absolute paths, which would be the only other way to guarantee that pip installs something precisely where you need it. Then you would need to use Python module with mpip or some kind of absolute path to the Python executable or to the pip executable, because this is all relating to each other. A pip lives next to the Python environment that it has been installed to. And if you don't make it match, then it's installing that stuff somewhere. So the environment helps you to contain these things cleanly together so that you don't need to bother with paths and where things live. And that's, for me as a data scientist, that's like one of the most time-wasting thing I don't want to deal with absolute paths. That's just horrible. And I'm actually, half of my time I'm spending on developing tools that are intelligent enough so that I don't need to take care of paths, and it's just intelligently working. And it frees you in your data analysis task really, it frees up your mind so much if you don't care what the absolute path is. It just works. It's all relatively based, or you have some kind of data manager like I'm usually writing for myself. The data knows where it finds itself and things like that. So absolute paths is just a waste of time. So Conda, in principle, by design, removes these needs from you and switches these virtual paths on by what environment is active. Okay, so let's look into this in detail. What's happening with these environments? So I show you this first on this slide, and then we actually practice it in the terminal. So creating an env this is all what you need, and it actually can be shorter, but I just added 3 example library names here. So what this means, conda create with a name n of pi37, and I want the Python, with this being based on Python 3.7, I need an environment that contains at least these packages, spicypy, matplotlib, numpy. And then conda gets cooking and finds all the dependencies that are required for these packages, creates a new environment called pi37, and then all these packages are together in this environment. And then you need to switch to it, and the conda creator, it actually reminds you about that fact. I will show you this in the demo in a second. So conda activate environment name switches then between these environments and sets the paths correctly. By the way, I will mention this again, but let me mention this more than once because it's very important, because that's the other major reason for people having issues with conda. Conda changed this way that's working somewhere 2 or 3 years ago. People had manual path manipulations in their shells to switch paths around so that conda was working. This needs to be removed from your shell config files, because conda has a setup section that I show you later as an example. It has a certain look to it where it self-configures itself correctly. And this and only this part should be in your shell config file. Anything else, like manual path settings to anything related to Miniconda or conda, needs to be removed because it confuses the whole path management system. Okay, so I will mention this again in case you were picking up a coffee right now, because this is very important. Let conda do its job, because that's exactly the whole design idea, that you don't mess with the paths anymore, because conda does it for you, and it switches dynamically the paths to even the installed binaries that conda installed for you, like GDAL. When you switch the conda activate a different environment name, it switches to different environment and therefore different available binaries as well. So you could even try out different GDAL versions if you have a problem with one of them. You just create a new environment with different GDAL in that. And we can talk about this detail if somebody wants the detailed instructions for that. But this is the power of it. It manages in your terminal all these paths dynamically. Now, some people work with maybe supervisors who have the need for Python 2. If you have no other, if you have the reason, let's say somebody tells you, I need you to work with Python 2, then this is the way you do it. Python equal 2, it will find just the newest Python 2 version that's available, and then the package name, and you create just like that. Just with Python 3, you create your own environment. And then you have to, and you can separate, and you can happily live together with a Python 3 and a Python 2 environment next to each other. You just do switching using conda activate, and no problem. That's also very nice. It's completely isolated from each other. But these packages are, of course, binary, not compatible, so you have double the data usage in this case. All right. Demo time. This is a list of commands I will now practice. So how about I try to send that email quickly again, because then people have these commands and could play on their own. So let me, I stop sharing for a second. push out one more email from somebody who joined later. Chase. Okay, that one. Slides for conda. Okay, a message is sent. If somebody could tell me in the chat if they see the message, that would be great, so that I know that it's there. And I will share my terminal now. And try to get my chat back. Come on. Okay, somebody got the email, so I think that means it's gotten out. And I will look at my slide, the demo time, slide 9. Use it as a cheat sheet myself. So can people see my terminal? Oh, I wanted to change its shape because it might be better for your resolution. Okay, Carlos says, see my terminal? I will change the shape a bit because I might improve the resolution for you. And I can make the font bigger, yes. But maybe this already helps, but yeah, I will make the font bigger. Out of interest, did that help at all with the resolution by reshaping it? Ah, yeah, okay, it did. So should I still make the font bigger? It's good? Okay. All right, cool. So in case you see something funny, I'm using the fish shell, not the bash shell. It's just my favorite one. So don't be surprised if it looks funny, but you can see on the right-hand side, I have my environment marker here, and some people are different on the shell. You have it on the left. That's of course all configurable. It's up to you, but okay. Conda env list. One of the most useful commands. It shows you what environments you have. And with an asterisk, a small one here, it indicates which one is currently active. So that's like, in case you would not have a clever shell that tells you which one is currently active, this command would at least tell you which is currently active. All right. So that's a very useful command. Now, conda searches for a package, like let's say NumPy. Conda search NumPy. And I want you to point a few things out that you see there so that you understand what you're reading here. So first NumPy, then version numbers, that's clear. But the next column is the so-called build identifier or the build string. And that's very helpful because it tells you in the front for which Python version it was built. So Python 3.8, Python 3.7, Python 3.6. So sometimes when you look, let's assume your supervisor says you need to use this version. And so let's try that out. Conda search NumPy equal 1.12, because your supervisor says you need to use NumPy 112. And if you do this, the response you see is already telling you immediately that there is no Python 3.7 and Python 3.8 build string, which means the development of this NumPy library stopped at Python 3.6. So now you would be knowing that, okay, then I need a Python 3.6 environment if my supervisor tells me I need to work with NumPy 112 for whatever reason. I don't know a reason, but if you're very highly into modeling math and maybe the numbers change slightly, the string, the definition of Monte Carlo, certain environment, I don't know, array manipulation. Can be a million reasons. But if you have a reason, and of course it can be not NumPy, but a different thing, that's the first thing you do. If you know you need a new environment, first you need to find out, okay, what Python number does it need to be? Because I have some constraints and version numbers. So you construct the search, and then you know what you need to do. Now, the next thing I'm practicing on slide 9 is the info edition. And I know conda info works as well, but they are going to removing that command soon. They changed that to be conda search. And then you have to use, like I was saying in my slide, to do info. And that gives you a detail of the Python dependencies that this package requires. So that's kind of helpful as well. And I have to say, this is a little bit easier done in this new C++ library, Mamba. It can show you nicely a graphical tree of the dependencies. So that's kind of powerful as well, but this is also workable. It's just, you know, you get a lot of information back here, so you would need to filter it out and search through it manually with your eye. So that's kind of not my favorite task to do. But sometimes it's required, right? So you need to know, is this, what does it require? And as you can see from the build string here, 536, you can see this reflected here. Python has to be larger equal to 3.6, but smaller than 3.7, because it was built for Python 3.6. And as you can see, NumPy is using Fortran underneath and some C++ as well. So it has this as requirements. And MKL is this Intel chipset accelerator for some math calculations. So these are the dependencies of this package. Now I created the 3.7. Actually, I should have written 3.8 because I currently don't have a 3.8. I want to show you how easy it is to create this environment. And because I have not talked about channels yet, I will go to my base yet. Yeah, sorry. This is actually one more thing before I switch. The last column, I didn't tell you about that. So the last column, which is oddly formatted here, so let me do this search, is nicely formatted here. The last column indicates from where this package comes from, and that's the so-called channel, the channel philosophy, and I will talk about this a bit later. But this is basically indicating to you, this is main, so the default channel from the Anaconda company, or Conda Forge, which is a huge user-supported channel system from where all the packages are also available. And just as a heads up, I'm using Conda Forge for many years successfully. I'm not using, because I just like newer versions, because they move slower on the company side. They are moving faster in versions in Conda Forge. But if you love stability and don't care about newest version, it's also working very fine to stay on the main channel. But how this is working, I'll show you later. Now, conda activate base. Oh, an important command I forgot here, not conda env list, but conda list. That actually shows you all the lists, all the packages that you have. And as you can see, I don't have very many. Like zlib is here, and that's the beginning. Almost fits on one screen. And that's because I'm not working in this environment. This is just whatever conda needs for working properly. So, and I switched to this because the base obviously is looking at the default channel of the company, because I don't want to switch it even. So, and that's important because all these commands like conda create, if I would have started that in my other one, it would have started from the Conda Forge channel, because I have configured that other environment to live in Conda Forge. And then it becomes just a little bit more complex for you to follow it now. So I didn't want that part now. So, but if you want to start, you can always force it to look at the default channel. But if you want to start from scratch, clean, just activate the base one. And you can see now my environment is base here. So that's fine. Carlos asks, is there a way to delete the non-essential packages from the base other than one by one? I'm saying don't touch the base, because there is a reason why unless of course you accidentally installed, I guess that's the case. You or not accidentally, you were working in base, and now following my advice, you want to create your own environment, but you have all the extra stuff now in base. Yeah, okay. No, unfortunately, I don't know of one. So I think actually it would be easiest to just wipe it and reinstall it. I mean, it's so fast these days. Instead of going through all the detail of figuring out how to control it, I would be too lazy for that. I would just wipe it, remove the whole Miniconda or Anaconda folder, and start from scratch with the installer. It's so easy. And I didn't go through it, but there's this script-based installer which just work via the bash shell, but they work as easy as the graphical one. So I wouldn't be worrying about this too much. If you want a clean base, just start from scratch. That's what I recommend. It's really the easiest. Okay, let's create an environment. Go ahead. So create -n. And as you see from my list before, this is the result from the listed packages, but what I mean from the conda env list, let me show it to you again. I don't have a pi38, so I will create that one now. Conda create -n pi38 Python equal 3.8, sorry, 3.8. And like this, it only gets the minimum files, and that's it. This is the minimum that the environment needs. So I just press return because the Y symbol is activated in brackets. So that's the default response if you just press return. And I guess it needed some updates. No, I never had any 3.8. So that's why it needs to download files. If you already have downloaded the correct files, it would just hard link them. So it would be much faster to create a new environment. Okay, while this is happening, I can read the question here. Just to be clear, I keep the packages in base. The packages, I don't understand the packages. The packages in base and create my own virtual environment of packages I need separately by downloading them again, assuming I'm using. I don't understand this because I personally don't tell Conda what to download. I only tell Conda what I need, and Conda manages the rest. If you manually manage somehow, which I don't even know how, what Conda downloads, then I admire that hackery, but I wouldn't know what's happening there, and I would not advise it. Oh, okay, so you're just using install as well. So then I don't understand the phrase, I keep the packages in base. You mean you don't touch it? Yeah, okay. And then you create your own virtual environments of packages I need separately. Yeah, and by downloading them again, oh, I see. So I think what I understand from this now is you started with an Anaconda install, meaning your base is pretty large because it has a whole Anaconda thing. So it has many packages in there. Yes. So, and yeah, it feels like a little bit of a waste, but it's actually, as I said, the packages are hard linked. So even when you started with an Anaconda install and you now feel sad learning in my talk, hey, maybe I should start it with Miniconda, don't feel bad about that waste because it's not much waste. Just create a new virtual environment and leave that base Anaconda, even though it's large, just leave it untouched. My base Anaconda is small because I'm working with Miniconda. But if you started with Anaconda, as I said, yeah, you have a big base environment, but it's actually not downloading them again if the version number matches, but hard links it. So you're actually not wasting complete space, just a few packages that cannot be hard linked, as I said before. So I wouldn't worry about that. You started with an Anaconda and now want to work with your virtual environments, that's fine. It's in today's space doesn't cost anything, mostly. So yeah, I wouldn't worry about it. If you need any megabyte, then of course, I would wipe it and start with a Miniconda install if you're really worried about that gigabyte there, which I think you only maximum would have wasted 300 megabytes or something, or 200. And as I said, if I go through the mental task of several hours just to find space for 200 megabytes or wiping the whole thing, I would always prefer wiping because it's just so fast. All right, so the install is done. you see here now, to activate this environment, use conda activate. So it tells you what to do. So I do conda activate. pi38. See, now my base indicator changed to pi38. So in conda list just shows this few packages. That is the minimum for a new environment. It might be that my base is already a little bit dirty because it has more than this one package, or this might be a development over time that changed where conda maybe at some point needed these other libraries and then decided they don't need it anymore. Could be that. Oh, no, I know what's happening. See, in this environment, I don't have a conda itself, the binary tool, because the binary tool always points to the base environment. So that's why I don't need all of the same libraries like in base. This is only the libraries I need for a new Python-based environment for doing science or for doing analysis, not for managing conda. That's why it's less libraries. So now I could do conda search numpy equal 1.14 just to check if that exists in newer versions. And there I see there's a Python 3.8 version. So if I need to restrict myself on that version, I can do this now in this new environment. Conda install numpy equal 1.14. And as you can see, it actually did this very quickly, much quicker than in previous years. It failed with an initial frozen solve, and that's basically a status of the environment so that future conda solver questions are faster. Solver is the thing that's calculating the dependencies between things. And it had a frozen state, but because it's a new package, it cannot use the frozen state, so I'm retrying a different way of solving things. So it's just a little bit feedback to you how conda works. And then it found dependencies for this new package, and it's installing them. All right, and that's that. And now you have at least NumPy, and of course, there's many packages missing. So a little preview of what I usually do. I have this text file, and that's just a list of packages. So, and I can point the installer to this conda install with a file, -- file, and I do that. And then it will get all these packages. And that's how I can be so fast in wiping everything. Yeah, this is actually not working because I'm getting packages from conda forge. So let's talk about channels next. Or no, I think I talk about the pip problem first and then talk about channels. But see, this is failing because I'm actually asking for packages that don't exist on the Anaconda company server, the default server or the main channel. So it says, well, not available. So I would have to do like this little flag, -c for channels, conda forge, and then it's looking at that other distribution channel for packages. And it will try to figure out a version set of all these packages that match. And it might have a hard time because I'm now having an old NumPy there, and it needs to match the old NumPy. Or it might ask me to update the NumPy. Let's see what conda does. I think conda respects now these manual installations of the version numbers. Yep, and it does so. And see it, this is a good thing to learn to read. This now, because I'm asking the conda forge channel for packages, it switches some of the already existing packages. Yeah, and it didn't respect my version number, unfortunately. And this brings me to another topic I will talk about later, how to pin packages if you need to, so that conda update or conda install doesn't change it underneath you without telling you. But yeah, this is important to read here. These packages have switched from being delivered from the main channel to the conda forge channel. So this is something you need to keep aware of. If that's happening and you didn't want that to happen, then you can tell conda, no, don't do that. Stay with that channel that I prefer. So we talk about that later. All right, so, but this is a huge list of packages that will come down now that fulfills all my wishes of this. See, it's a lot. So, and I think I only define 50 packages, but the dependencies then makes it to 120 or something like that. I might even only define 20 or 25, but all the dependencies coming in is a lot. So I don't do this now for time reason and go back to the presentation. Is there any questions so far? Share screen. All right, so 1 hour already gone. Let's see that we go ahead. Demo time. So my Python package search tree, I call that. And that's basically just for my sanity that things maximally work with each other without creating me any problems, or at least the minimum set of problems later on. Hopefully the font is not too small here. I can stretch this a bit. But yeah, you have the copy of it, so you can have a look at slide 10 yourself if it's too small. So first of all, always try Conda, because if it comes from Conda, it matches this environment system checking and version number checking. And pip does it slightly different. So only go to pip once you haven't found it in Conda, and Conda search doesn't give you what you need, then go to pip. And if you search for it, I recommend you to read that article, how Conda and pip works together. There's an article that has a little bit more details that I'm saying here, but the essence is the same. That, well, actually, they're a little bit more dramatic about it. They basically say once pip changed your Conda environment, it's so dramatic that Conda really doesn't know about it. So you rather recreate the environment if you need to change something now. And I have to say, I very rarely meet that kind of dramatic end result from using pip. I'm using pip all the time, but maybe I'm using pip only for libraries that are safely put together. And what I mean by safely, I'll tell you in a second. Yeah, Carlos asked about Brew. The problem with Brew is that Brew doesn't have either a way to tell Conda in what kind of thing they're working in terms of, so you could accidentally, well, first of all, the Conda path is superior to Brew. So if the same thing is available, Conda does and should be preferable in terms of finding libraries. But the cool thing is, if you have a library that Conda is not offered, then you can install it with Brew. That's a package distribution manager on Mac, by the way, for the people who are not on the Mac. Or maybe it's available elsewhere now as well, but I think it was started on the Mac. So if something is not available on Conda and you install it with Brew, Brew is completely independent and it's just path mixed into in being available. So that's cool about it. It doesn't touch your Conda environment, so therefore you can do with Brew what you want. But of course, you could run into the issue that Brew installs something that's only working for Python 3.8 while you currently want to use it in a Python 3.7 environment. But usually that shouldn't be the case, and here's why. If it's something with Python 3.7 or 3.8 related to, you actually should manage that in Conda, not with Brew. What you should use Brew, and I'm using that also successfully, is install computational libraries or something that's not even offered by Conda at all. So, and then it actually nicely merges this on top of your current Conda. Conda gives you the path of existing libraries. And when you Conda activate environment, that's findable. And if there's a certain library of a computational system that's not offered by Conda, your path system of the shell will just look next in the path, and it will see the Brew path and then say, oh, there's the C++ library that I was looking for. And then it can just harmoniously collaborate with your Python tools. So Brew and Conda work really well together in this way. If you do the Python stuff consistently in Conda and do all non-Python stuff in Brew. So don't try to mix Python management in Brew and Conda. That's just like a recipe for disaster. and I wouldn't even touch that. So yeah, so I guess Carlos has experienced that. No, you have to stay consistent at least on the Python side, and then let the other libraries that are not offered on Conda, let that be done by Brew. And if you do that, you have a happier life for sure. Now with pip, what can happen with pip? The problem is pip looks at these library version dependencies on its own, doesn't talk to Conda, and if an author of a package, and I had that recently, if an author of a package says, hey, I need from this library version 3, but Conda is already on version 4. So what happens? Pip sees that the author of this pip package says, I want version 3. And pip does that. Oh, geez, you have already version 4 installed, but yeah, I don't care. I don't need that. You asked me to install this package, so I will remove this Python with this package 4, and I will give you version 3. And now your Conda environment is messed up because Conda doesn't know that pip replaced this package. That's the problem. And there is no clear solution for this mess on the horizon. The cleanest solution is to ask the author or help the author to create a Conda package. And it's a little bit more work than a pip package. I know myself because I'm trying to do both. But pip package is so much easier. So it's the lazier way around currently. But if you're a scientific library developer, please add also Conda packages. I know it's more work, but if everybody puts in some work, then we can create Conda packages, and then it's a much safer way to install them. So, and these are all the caveats. Now, having said that, there's a lot of pip packages I'm installing, and they're just cleverly designed that they don't have this very constraining version requirements. They're just happy when they get that library with that name, and they don't care about the version, because usually you don't remove functionality in the future. That's the so-called breaking change. So things still work. So yeah, with that caveat, pip install if you don't find it in Conda search, and it works fine. Now the next thing is if you need absolutely newest software or something that's not where the author doesn't have time to even create a pip package, then you can go to GitHub and see this command line here at the end. You can clone a GitHub repository. You can then cd into it and then do pip install either -e or not -e with a dot. The difference is if you plan to develop in this library, then you install it in so-called engineering mode, or maybe it stood for something else. I always thought it's engineering. But it's basically installing this library in development mode so that your changes are immediately known by your Python environment if you develop in this library. If you don't care about that and you just want to install it, then remove this -e and just do pip install dot. Remember the dot? That's for installing something that's in your current directory in the bash. So I'm using this mix for many years. And I think I now already went over all these problems here, but let me quickly summarize that. The conda-pip frenemies. So pip is good in itself. It checks dependencies, but it checks dependencies as defined by the package author. And we're all humans. We could be too constraining or didn't have time to go with the time and update that package library requirement that I put in there. And then it accidentally messes up people. And then hopefully people create a GitHub issue so that I can update that. And I recently did that, and the author also improved their package, and now it's much less dangerous to install. So pip is recommended even over the so-called Python setup install that was for a long time the old way to install Python packages, simply because it keeps a good record of what it did so that you can more cleanly uninstall it. With Python setup install, there's no 100% clean way to uninstall it. With pip install, like this, pip install dot, you can do it then later on pip uninstall package name, and it cleanly removes it. And that's not possible the other way. That's why I recommend pip install dot. However, as I said, pip does not tell Conda what it did. Oops, sorry. We had this. So while Conda still thinks the newer one is installed, that's the dangerous part. Pip has removed it with an older version. Now, the lemma in mathematical logic, the lemma of this is the never run pip in the base environment, because it could completely mess up your conda-based tools that Conda needs. And the corollary out of this is I have proven to you now the theorem that you need envs because of this. Because at some point you might need, or most likely you will need to install a pip package. And you just don't want to go through the hassle on messing up your base environment. That's why you need, another reason why you need environments. All right, now what is, of course, what happens when it happened? Not as such a big deal. Usually this process should work. You uninstall that package name. Oh, by the way, how would you figure out that this is happening? Pip always gives you a summary of what it did at the end of all this printout. So keep remembering that. Check what pip does. And at the end you see, I installed that, I removed that, I put that in place. And if you don't like it, you can reverse it by this. Pip uninstall that package name of the library you know for a fact that Conda already had installed before. And then, but now there's an empty space. Conda's management system still thinks that package is installed, but you just uninstalled the binary for it in that folder. So what you need to do is to tell Conda to reinstall it, even so it believes it's still installed. And you do that by force reinstall. So that's how you get out of this iffy situation. Now, if that was with for one library, I would do that. If pip, because it had a huge dependency trees, replaced several of your packages, I actually would rather vote for replacing and make a new environment. Just because the dependency trees become compromised in a way that maybe Conda cannot repair this, and pip did a change that then is a different dependency tree on the Conda environment, and I wouldn't just go through that hell. If it's one package, I do this repair. If it's more than one, I just make a new env, and you learn with me how easy it is. All right, now I have a summary of everyday Conda tips here, and I hope it's not too small. I actually can zoom in a bit. That's too much. I'm not sure I can control it. I can do it a little bit wider. It grows a bit. Okay, hopefully that helps. All right, if you have installed Conda before, and it's older than Conda 4.6, I also recommend you to remove and reinstall the whole Conda environment, because there were so many changes there to 4.6 and maybe even partially to 4.8, but I think they managed a way to clean everything up in the internal updates. But if it's older than 4.6, I had problems when I did that update. So I would recommend you to wipe everything and just start from scratch. It's the cleanest, and you don't want to have that old craft creating new problems with it. And everybody says, hey, I'm happy with Conda. Why am I not, right? So that's why I recommend just wiping it. Now, that's the other thing. Let me say this again. In your bash or C or TC shell configs, if you have path changes in there that point to your Conda, and I have a screenshot about this in the next slide, that point to your Conda install somehow, and you manipulated the path to make it work, that needs to go, because Conda changed in 4.6 how this is working, and that needs to go away. And this is also mentioned in the documentation and on the websites of Anaconda, but of course we're all busy and not everybody's reading documentation as manically depressive as I do. So that's just an important thing to remember. Yeah, we talked this. Initial conda-based environment, maybe don't use it. I just like to leave it alone, because I like to experiment with environments just to check it out for libraries. So, and I have the confidence that I don't mess up my base when I do it in my own environment. And this is how easy it is. Conda create with that, Conda activate. And then you're in the new one, you search and you do install, or you do install the whole file like I showed you before. Now about the shell config again. Keep your shell config clean. This is the only thing, and I think this was a bash shell, I hope. Yes, this was my bash shell. So this is the part that Conda installer puts into your bash shell. And by the way, if you don't have this in your bash shell, you can force to have it, to get it, by saying conda init bash or conda init your favorite shell. If you have a different favorite shell, then it will rewrite this configuration string into your config. So in case something went funky when you installed it, or maybe you changed your shell and Conda is still not configured correctly, this is how you do it. Conda init and your shell name. And then it will recreate this section in your configuration. All right. So there, this is the conda setup function, and it sets something up and then unsets it. So don't manipulate this on your own. Conda does its thing, and it's kind of sometimes magic, but it's cool magic. It's the good kind of magic. So I would really not touch it, and yeah, just enjoy that the paths are working when you use Conda environments consistently. All right, questions about this so far? Otherwise, I switch to channels. I don't see questions, and I don't see an urgent waving of chase that nobody can hear me, so I guess everything is working. Yeah. Okay, looks good. All right, let's go to Conda channels. So yeah, you might think, of course, that this is another dimension of complexity, but it's a helpful complexity because somebody needs to design all these packages and make them work together. And the company, specifically a company that is focusing on trying to earn some money, cannot do all the work for us. So, and they're giving this out for free, right? So I think you have to cut them some slack that they don't do everything perfectly. And the perfection that some people were missing was the being up to date with the developers of the sub-libraries and keeping that maintained. So there's a whole bunch of people, private enthusiasts, open source enthusiasts that got together, and then many of them scientists I know personally, having met them on Scientific Python Conference or something like that. They dedicate some private time, or maybe also finance time, I don't know. That's a detail up to your discretion. But they dedicate the time to make these packages work and be more up to date than what Anaconda offers. And that created this big alternative channel called conda-forge. And it's highly complex if you develop your library. I even didn't go through that effort myself, but maybe some people in listening to me now have done it already, creating a conda-forge package, because it has a big automatism underneath it that checks for problems automatically so that everything in principle should work being tested if you wrote your tests correctly and so on. So it's even if you think, hey, this is all user home-based bunch things, why would I trust my science libraries on that? I think it's quite reliable. I'm using this for many years reliably. Of course, like once per year or so, there's a big hiccup of something, but you can always go back versions if things are messed up, and then you wait with an update for a while until things are calming down. And there's good discussion forums about this. But yeah, I think you really can trust this conda-forge channel, and it's really much more up to date in terms of libraries and bug fixes of libraries that everybody of us is using. So channels are just different pointers or locations for the sources of packages. All right. So by default, an environment is actually pointed to this default channel, and you can confirm like so if you do conda config show sources. That actually shows you what this environment that's currently active, what is it looking at for defining things. So in this case, I have two config files even. I have one in my home directory, and I have a config that's environment-based. And that's a very important and useful distinction. Why? Because maybe you don't always want to use conda-forge. So you shouldn't define your favorite channels in the base conda environment, but you should actually switch your environment to prefer the conda channel. And that's the so-called environment-based configuration, which I tell you all about it. And I think it's a little bit under-advertised. This is an ingenious way to ease your workload by not constantly remembering, oh, I need to switch to conda-forge channel or this channel. Or for example, I'm working with USGS software. So I have another USGS channel, and then I have my own private channel where I develop conda packages and I want it from them. So I have 4 channels already to manage. And I don't really don't want to mess up my other environments with that kind of mess. So I configure things by environment, and that's possible. That was one of the biggest, for me, inventions by Conda, that you can differentiate this kind of settings. So what you see here under channels for this environment, nothing here, but this environment Pi 37, apologizing, this dash here. Oh, maybe this is outside the sharing frame. Might be. Maybe now you see everything. Might have been outside the sharing frame. I'm seeing a frame here that maybe wasn't showing you everything. Okay, hopefully now. So, you could see everything? Interesting. Okay, then I don't know. Then maybe I drag it out a bit so that it's a bit bigger. Okay. So channels lists the channels that are being sourced here. And the top one is always the priority one. So conda-forge is priority. But then if something is not available that matches my version requirements, it's also allowed to look at defaults. And I never tried it, but I guess you can remove it. But that would be a little bit more restrictive, of course, because defaults is kind of some background libraries. Maybe sometimes you need something, but actually as a general rule, and damn, I forgot it. As I write it in big letters, and some people have written blogs about this, don't mix channels. And that's especially true for GDAL, because GDAL is differently organized on conda-forge than it is on the defaults channel. So if you mix the defaults in the conda-forge channel, things will not work. Import of GDAL will fail and things like that. So if you can at all avoid it, don't mix environments. A little package here or there, like MKL library or something like that, might not be too bad. Sometimes it needs some kind of, like I'm using Number, this just-in-time compilation. Sometimes it needs a little library file for the LLVM compiler system, and it's not available on conda-forge. It gets it from the defaults, so that's fine if it's like one or two packages here or there. But in general, don't mix the sources for a whole environment. You can mix it in different environments, but not within one, okay? That's an important point because that's more consistent. And how you avoid mixing it, because the environment solver, the conda solver, could see that defaults has also a matching library and then just suddenly go there and say, okay, I found something that matches your requirements, so I get it from there. To prevent this, you use the system called pinned packages. And I'll show you commands about this later. But basically, looking at this with the conda config show sources, it confirms that I have pinned these packages to only come from conda-forge. And that tells the conda application tool that it will not consider for these packages to come from the defaults channel. And that's just for me, for my sanity, to keep it a bit cleaner with this all libraries. Don't mix the libraries underlying OpenCV with something from defaults or something. That's helping me to keep the environment more stable over time. Because when you do a conda update all or something, which I like to do because I love updates, even so they could break things, I always love to have the newest things because mostly it's bug fixes or new features that I can play with. So I love doing updates, but having these pinned helps to be my updates to be more stable and not break my environment. So that's just saving me a bit of time. If it doesn't break so often, then I don't need to recreate so often. It's just saving time. And how this works, I show you, I think, in 2 or 3 slides. I demo this. But this is how you confirm it with the conda config show sources. All right, a bit more on channels. What if you want to have one environment pointing to defaults and one to try out conda-forge? Exactly. That's what I mentioned already, environment-dependent configuration. So you activate the environment you want to configure, and then you do type conda config, not add channels, but conda config env add channels, and that will point to the currently active environment. I think you could also switch to it with a with a -n switch, but that, yeah, it would be a different way to achieve the same. With env, it uses the current active environment. And this is, I already said, don't mix channels if you can. All right, pinning packages. Because conda sometimes finds better in its own definition packages at default channel, conda then tries to mix it. So to avoid this, as I said, it's catastrophic for GDAL. Pin packages per environment. And I would recommend you, again, to do it per environment so that you have all the freedom to do a different thing in a different environment. So don't configure this in the base config file for conda, configure it in your environment. And that's how you do it. Conda config --env --add, and then pin packages. That's the item you want to add to the configuration. And then that's the value you want to add to the pinned packages section. Conda forge is the channel name, ::, and the library name. And you could even add version numbers here. So you can pin it down to certain version numbers or even to version number ranges. You could, for example, say if you have a problem with GDAL 3 that was recently released, you want to stay with GDAL 2, then you could say here, conda forge GDAL smaller than 3. So you can configure everything in detail what you need for your libraries, and Conda would consider it because you have manually configured it now. Remember when I first did this install, because I didn't have anything pinned, Conda had all the freedom to do things, and it wanted to do the good thing and update my very old NumPy version and gave me NumPy 118. If you need to stay with 114 for some reason, you pin it like this. And you actually don't mention, if you don't care about the channel, you can just pin the package name itself to a version. So you could say GDAL smaller 3 on its own, and then it would still look in defaults channel and mixed environment, so it's still bad, but you would have solved the problem of the version alone. So sometimes that's enough. But as I said, sometimes it's nice to pin it also to the channel itself. All right, demo time. Slide 18 is the commands I want to demo now. So stop sharing this. All right, so you get the chat back. All right, quick feedback. Can people see my console again? Okay, thanks, Carlos. Now, so I created the Python 3.8 already. No, but last time I created it from defaults. So let me quickly show you another command, which is conda-env remove. Even so, we practice that later as well. But conda-env list. See, I have Python 3.8, Python 3.7 now, but this 3.8 was incomplete, so I just remove it for now. But of course, you cannot like pull the carpet away underneath you standing on it. So meaning I need to conda activate base or just deactivate to be able to remove it. So conda-env remove. And actually, a little warning, this command recently became more dangerous because they forgot to re-implement the extra security question. So doing this command will remove the env and it will not ask you again. So there was previously a yes/no question. And when they updated Conda, either they forgot or they decided to get rid of it. But it's not there anymore unless they re-implemented that, and I will be surprised. Yes, I have to put the name tag, -n for the name. Conda-env remove, and then -n, and the environment name. And see, it didn't ask me again. And if I do conda-env list, and it's gone, okay? So first command, create a 3.8 environment, but this time using conda forge. Now, if I do conda config show sources in here, see, I have nothing defined for the base environment. That just means everything is default status. So I didn't touch anything. And this is why by default, if I do this, create. So create environment by 3.8 like that. If I do this, it actually points to the defaults channel here. It's called main. That's the defaults channel. So I don't want that. So I do not here, n here. And now I switch to use conda forge. And you see immediately in the answer, that's now pointing to conda forge. See, So this is good feedback. And this is for me a much more immediate feedback than I have from the GUI. So that's why I prefer this a little bit more. So I press return for yes. It's creating now this, and yeah, because before I downloaded the default version of 3.8 and now it's the conda-forge version, I need to download it again. So sorry for the delay, but that's a different binary product and I cannot hard link these next to each other or on top of each other. But this is good. This is for consistency. I've never seen, Carlos asked, let's say a friend of yours, some friends you have, created an environment without a name. How can they remove it? It's a good question. Never had that case. However, I think you can dig into some of the conda config. There is a cut home. Let me check this. Conda / environments. So there's a list of this, and I would be really surprised if there isn't an entry for this nameless environment that you then could go there and you just remove that folder. That's as simple as that. You remove it from this environments.txt file and you remove that folder, and then you're rid of this nameless environment. Okay. All right, so conda, where am I? I installed it, but I didn't activate it yet. See, it said conda activate py3.8. Conda activate py3.8. All right. So now, one more pitfall to overcome. So take note of that. If I didn't put in the slides, you installed it via conda-forge, but unfortunately, that doesn't mean it remembers that. Because if I do conda config show sources, nothing has been defined. So this is one of the big confusions for beginners in Conda. They do a Conda update now, Conda update all, but you just installed, right? But what happens is that your default points to the main channel because you didn't configure it to always point to conda-forge. So it just doesn't have this long time memory of what you did. You really need to configure what you want Conda to consider. So it points back to the versions that are slightly newer, apparently, on this other channel. So what you need to do is actually configure it. And sorry, I was just confused. I still didn't do conda activate. See, this points for package to package, main to main. So actually, it didn't show what I wanted to show you. Conda activate py3.8, right? So now if I do conda update all, it points from conda-forge back to main. Because, and I need to reconfirm this, conda config source sources. See, in my Python 3.8 environment, I have no sources otherwise defined, meaning it points to default, meaning now your installed conda-forge packages, when you do update all what conda knows is I only look at default, and then it finds other things there that you have and says, yeah, well, you point to default, so I better get the default packages. So what you need to do is, after you started with a conda-forge configuration, is you need to consolidate that configuration. So you do conda config, and you can put this all into bash scripts. That's the genius, and that's what I did with my quick backup scripts or my recover scripts. You put these commands all in some bash scripts, and then you can be re-executing them much faster. So conda config, remember the environment switch, and then add channels object, and then conda-forge. Okay, now let's check that again, show sources. See, now I have this. Conda-forge and default, conda-forge is on top. Now if I do conda update all, it should not complain. See, all packages installed, and this is because I started with a conda-forge install. So these really should be all up to date because I just did it. All right, so that's the big difference with the channels. You have to configure where conda is pointed to for looking for updates, and that's the channel management. All right, what else do I have? Add channels, I just did. Show sources. Ah, yeah, now the pinning. So now imagine like my preference is pin conda forge to GDAL. Sorry, other way around. Pin GDAL to conda forge. So conda config. Remember the env switch, and I want to add a config object, and that config object goes into the category of pin packages. And what do I want to pin? I want to pin to conda forge the package named GDAL. So yes, it's a little bit of cumbersome syntax, but I think, for example, correct me if I'm wrong, but I don't think this is possible with a Anaconda navigator, this kind of detail of configuration. And this is why I always felt helpless. Maybe they have put it in now, and if somebody knows that this kind of configuration is possible, Carlos thinks it's not. Okay. So yeah, see, if you need this kind of sophistication, and I think it's good because it just keeps your updates more intact. And if you cannot control this detail, you just don't know what the GUI does. And you do an update, and suddenly after the update is everything broken, and then you're frustrated. So really, I'm afraid, in my political opinion, or in terms of business decision, I maybe would have not offered the navigator because it never does an as perfect job in terms of control as the command line. On the other hand, maybe you then have less user base because if there's no GUI, then everybody is scared and they don't even start to use it. So it's a balance, I guess. But maybe you could argue that let people start with the navigator, and once they're confident about the system that it works, then let's have them use the console, because that actually gives you the control of what you want to control. For example, that an update doesn't mess anything up. And seriously, you are fully right in saying, why does it mess things up? Yeah, and I agree, they shouldn't. But I think it's this mix of that the open source development, to our own benefit, is going forward ahead and develops faster than the company and throws out these library updates and bug fixes. And if they wouldn't do it, then our progress would be much slower. So to keep up with that progress, we need to work in different environments. But then you cannot force the company to spend the money on managing this other environment as well, right? So they have to protect their own financial capabilities. So it's this give and take with open source. You need to do a little bit more work for the fact that you get these things for free. That's just a deal. And for me, even the deal includes, I cannot spend time on fixing bugs, but I'm very dedicated in reporting bugs, because reporting bugs is what keeps this library in good shape. So please, 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 if you find bugs, report them as a GitHub issue. Every maintainer is happy to find a bug and fix a bug. And this is how we all can benefit from each other using this open source software. So please do that. Consider that the moral issue of using open source, that you at least report diligently when something doesn't work. And it might be that you don't understand things correctly, and then yes, somebody needs to teach you that you forgot to do this or that, but that's fine. And I think that's all a deal that we do. And we have discussion forums instead of issues where you could start asking about it. If you don't want to bother the developers with something maybe you don't understand, start in the discussion forum and ask the question there. And then somebody from the devs will say, hey, I don't understand this either. This looks like an issue. Please file an issue for that. And yeah, becomes more work. Yes, I understood that, Carlos. You can add channels, but yeah, you cannot go to the detail of pin and packages. That's what I understood. Okay. Yeah, so I think it's just a nice social contract that we have with open source developers and open source users. So the users report the bugs diligently, and we still get updates. So I think that's a cool deal. And yes, we might feel like being slowed down, but otherwise we wouldn't have anything. So much for my pontification. Sorry. But let me check this. Yes, I did this already, huh? I can actually re-execute it. Yeah. See, it just warned me that it was already done. And see, now I have a pin package, conda-forge GDAL. And you can also, like I said, you can do this by version. And as a warning, depending on your fish, sometimes fish a shell wants to integrate that larger sign, then you need to escape it with this character, and then it will be correctly added. So I cannot copy this for some reason. I can just type it. Conda config and add pin package. I don't have it. Okay, so I do. Ah, here I have it. Yeah, see, I did this with the escape symbol in front of the larger sign, but that ends up being removed when you look at this. It's just number larger than 1.16. NumPy, sorry, NumPy larger than 1.16. Okay, so that's that for this demo time, and we're 20 minutes to go, and I think that's just perfect. All right, I want to tell you about one of the best or important kernels, and I recently had this issue of fighting somebody fighting this issue. And this is kernel management for Jupyters and IPythons. And this was a few years ago, some of the most nightmarish things for me, that you needed to manage these things manually. It's like you needed to type in, install this kernel. And for me, it was very wavy or hand wavy what even a kernel was at that time. It was still the new thing of Jupyters and IPython notebooks. And why do I have to manage this kernel, and what even is it? And now it's more clear to me. Kernel is just an interpreter on how you use this JavaScript-based notebook environment. And it can now have C++ and Fortran kernels and R kernels. And a kernel is just really this interpreter that points back to what your down installations of your Jupyter notebook or IPython notebook. By the way, a Jupyter notebook that runs an IPython kernel, it's still officially allowed to be called an IPython notebook, instead you wondered. Right, so how do you manage this all? So this poor soul somehow tried to use Homebrew, I think, to install things, and installed Jupyter, just the newest one. And it turned out to be a Python 3.8 Jupyter. And then she manually installed a Jupyter kernel fitting for this 3.8 for the Jupyter notebook. And then she used pip to install AstroPy. And it was the AstroPy of 3.7 was found, because pip was, there was somewhere a pip on the system that was 3.7. So it was then not found by Jupyter. And yeah, and this user said, I'm not advanced enough to do with conda and environments. And actually my first response was, well, you're kind of, the reason why you're in this pickle is because you don't save yourself with conda environments or with any environments, because any virtual environments would protect you, put this virtual wall around you to stay within this room of one Python environment. And that actually saves you a lot of hassle with installing packages and things like that, because the version management then automatically finds what it needs to find the right version, fitting to version to the rest of your stuff. Now, coming back to IPython and Jupyter kernels, in the old times, you needed to install them and make it known to your Python system that you have this kind of kernel installed, so that both Python knew about Jupyter and Jupyter knew about the Pythons on your system. Now, thankfully, there's a conda package called nbconda kernels that does this all automatically for you. And this is like heaven on earth, because you don't need to manage these kernels anymore. I really hated it. And that for me was a big reason of not liking even the whole thing with conda packages. And I still needed to do these things manually. It was a whole mess. So since this package, this is all not required anymore. So you install nbconda kernels, and then you have this luxury. If you have your Jupyter notebook open or your Jupyter lab, you click on selecting a kernel, and it automatically has found all your conda environments. See, this was from a time I had many more. And the Jupyter notebook knows about all of these without me installing anything. Just this nbconda kernels tells automatically the Jupyter notebook, when it launches, what all the environments are that are available. And then in your notebook, you can just switch that kernel and try it out on a different Python. How convenient is that? So this was really genius, this package, and it saved me so many headaches. So I highly encourage you to not live without this package if you use at all IPython and Jupyter Notebook, and I would be surprised if you don't. Okay, that's about that. Now we go into the meat of the talk, how to reinstall everything in 5 minutes, right? So even best religious practices make a stable environment. Actually, I called it here stable because in my old times, I called the environment of myself, my standard environment, I called it stable until after some playing around, I realized that's kind of a misnomer because the more I play around, the less stable it is. So why would I call it even stable? So I decided then it's much more reasonable, sensible to call it by the Python version, because then I never will confuse it. Because there will be advancements in Python and the version number changes. So maybe it's good that my environment immediately identifies what Python version it is based on. So that's when I changed to naming my environments like Py37, Py36, and Py2. And sometimes with the additional NOMA for testing, right? Py36 testing, or Py37 experiment, or a new library, or whatever. So that's of course totally up to you. But my standard working environment for certain things where I don't mess up so much, they just have this name Python 37. Okay, so the trick to have a quick turnaround time from a rotten environment that you need to wipe and come back to life with all your stuff is to have a bunch of script files and config files. Mainly a file with a list of your conda packages, and then a file with a list of your pip packages. And if you develop your own libraries, which I have a bunch of it, you always, of course, would then manually have to go in there, cd into your folder and then pip install. You can put that in a bash script or fish script or whatever, and put that all together. So it's a couple of scripts, and they go through this list, and I'll show you how this looks. So in the upper left, I have a little shell script that actually checks. I even give it a command parameter, which version of an environment do I want to install now. So it even asks for a Python version string and for the name of the environment. And then if it's actually currently active, it even says, you need to deactivate first. I cannot remove it. Oh, sorry. Good point. Need to stop sharing this. Sorry. Share screen. There we go. Okay. Now I'm back to showing slides, right? You see them? Okay, great. Okay, sorry about that. So yeah, here, I think I said everything, so it's not so much more insightful to see it as text words, but this is basically what I do. And here's how it actually looks like. So in the upper left, I have a bash script. It goes just a little bit, it has a command parameter of the Python version string and the environment name. And then it checks if that environment is actually currently active. Then it says, you need to deactivate first. And then when it's deactivated, I relaunch the script, and then the conda-inf removes that thing. It creates the same thing again with a Python version that I actually gave here as a command line, and then installs everything from the channel conda forge and as defined in the standard Python conda packages. So that's my bash script. And then you're actually already back at the status, at least with all the conda packages. Now you have a list of files somewhere. This is shown here, pip packages. So the few remaining packages that are not available in conda, you put them in this text file. And then you have this folder of your privately developed libraries. That's all libraries that I'm developing. For folder, in this folders, go into this folder, type, give me feedback, installing this, pip install that, go out of it, and go to the next folder. So all my privately developed libraries are installed in development mode, so they're automatically available if I do any changes. And then when that is done, I finally go to pip and only install these remaining libraries that are in this text file. So these two files, and I do this, conda deactivate, reinstall my environment with this thing, that's how I call it. That's the name of the script, reinstall env. Then conda activate that and install my libs. That's it. And that's basically it. So demo time. I show you how not scary it is. I stop sharing. I go back to sharing of my fish console. All right. And I'm faster in getting back. To see people see my console? Okay, thank you for the feedback. Right. So conda env list. So as you might remember, I installed Python 3.8 just with you guys. So Python 3.7 is my main development environment. And as an example, I just played around recreating an Anaconda base here. So, and by the way, you will see sometimes instructions for a tutorial to create a conda environment like that. And they provide you all with the instructions on how to do that. And that's pretty cool, because that way people who go through the effort to have an hours-long tutorial for you, or like a video on YouTube even, and the HoloVis people do that excellently. They have an excellent 3-hour tutorial for making really cool plot things and app development things with HoloVis plotting. That way they can ensure that their software runs, right? Because they have defined a conda environment with a version tree that was tested at the time they created that tutorial. So that way, even when new developments have broken things, with the instructions following to create a conda environment, you are now in a status to completely recreate the tutorial without any problems. So that's also the genius part of environment. And you hopefully have seen now how easy it is to create a new environment. All right, let's go. I'm in conda Python 3.8. So I have my scripts in here. I can reinstall. Oops, sorry. Oh, yeah, it's not a bash script. So I need to do, what do I need to do? This is a new computer. Maybe this is the first time I do that actually here. Could be. LASP reinstall. Oh, no, there it is. Oh, yeah, because it's a shell script and I have fish activated. I need to do bash, yes. I didn't give it executable rights. That's what's happening. Anyhow, so I can call it with bash. Okay. See, and now it says I need to use these kind of information. I didn't give it enough information. Usage, reinstall, conda environment name, Python version string. And by the way, on the first slide of this talk, there's a link to a GIST that gives you example files. Of course, you should adapt them to your needs. But if you want to have these example scripts, you can have a look at them at this GIST file. Okay, so let me call it like it wants to be called. So environment name first, Python 3.7, and I need to repeat it, which kind of feels cumbersome. I could code that better, but it was working, so I didn't want to improve it. All right, removing all packages. So it's currently it's already done removing. And now it's collecting the new packages again, and we'll try the reinstall, and we'll try to match it. And I have, I should know, I did already show you this file with all the packages in there. So it's using this for considering to find the new package version. And it doesn't work because I'm on the wrong channel or something. Yeah, that's a good demonstration. Oh, yeah, I think I coded something wrong here. Oh, yes, I didn't follow my own instructions. It wants the Python version string and not this. I used my own script wrong, sorry. I need to do this. Yeah, for a long time, I didn't have a need to do it. So it tried to remove again. I just saw it was already removed, and again, does not find, yeah, I changed that file. Sorry, this is because I didn't want to show you all my fish stuff, and this is a new computer, and I forgot to link that file here. So this is now at a different location. So this is just my setup problem. So I could have done a better job in practicing this first. So let me just get this file. It's actually a problem of that script. Yeah. This was my old location of this file, but now it's in this main folder, so I actually can just do this. So I had never hard code the full path. So I didn't do this nicely. All right, third time's the charm. Yeah, but this is because I changed my computer recently, so the file location of this config file was not the same as on my Mac machine. And Mac, as you know, Macs and Linux, they don't have the exact same way of how to name a home folder. They call it user's name and versus home login name. So not everything can be immediately be copied over. So and I changed from Mac to Linux recently. So yeah, it's downloading whatever is missing. I guess there was some updates or some kind of requirement relationships already changed. So that's why it needs to download some of the files, but it's not all of the files that it's downloading. And by the way, if you play a lot with condas installed, at some point you have a huge cache and it can take a lot of space. And I'll show you a command to clean this up. Because at some point you have a lot of packages that none of your environments are using anymore. So you can clean that up with a command that I'll show you in a minute. So it's in the recording, so it's not lost, so that's good. All right, so that was quite a bunch of packages. There's this famous Conda kernels package. All right, now I shouldn't forget to activate it for the next steps. Conda activate Python 3.7. And now I do install my libs, and this time it's a fish script, but it's just the same text as the other one. Yes. Also, this is the path of fish on the Mac was different than on Linux. So this is going through pip, and this is just a mistake of my packages. One of my packages is in a bad status. I didn't develop it well, but this is not a problem. Of course, you will have not so many different libraries and development status, but it goes through all the pip dependencies in my own dependencies, and then finds the setup and installs it. Yeah, some of my libraries, I am experimenting with alternative installation procedures that don't use setup at all anymore. But see, this is now it installed some more packages and my other libraries. So as a proof, I start an IPython now. And I, for example, import pandas. That's there. See, everything is there. Import, what else? I think I have even number as a default always. Yeah, see, so that's there. So I'm done. That's it. And I think that was still less than 5 minutes, I hope, even with the mistakes. But Carlos timed me good. 3 minutes 4, even with my hassle of having a wrongly configured file. So imagine if everything worked, I think it would have been 2 minutes 30 or something like that, 30 seconds less, or maybe even close to 2 minutes. So that's what it takes to completely wipe and start from scratch for an environment, not for the Miniconda system or Conda system, but for a whole environment. That's what you need. So I think I really recommend you to go through this initial setup work on getting these kind of script files, because then you have the confidence. It's like, things don't work. I don't want to repair it. I just start from scratch. And sometimes, you know, you don't have time to learn about the intricacies of conda. Sometimes you want to do your science, right? And I totally understand that. So at that point, you just say, scrap it. I know how to reinstall it. I have this presentation from Michael. I just follow that steps and reinstall it. And even if you have to type in the commands by hand that I just put into the script, even then, I think you can stay around 5 minutes to completely wipe your environment and reinstall it. Okay, with that, I'm done. I'm happy to answer more questions that you have, any other problems, specific things. But I also would like to point out we have a Conda channel in the Open Planetary Slack. So feel free to always go there with any problems. And if I'm around, I'm happy to answer. But we also have many other Conda users. So there's always someone, I think, who can help out a bit.